Sorry, please go ahead.
Okay, good morning, good afternoon, and good evening, depending on the location you are joining us. Thank you for joining us live today for Open Talk session. So, Open Talks is a new initiative from batteryline.com where we highlight the proven capabilities of our members in enabling scaling up battery production for gigafactories. So today we are happy to have Mr. Markus Roever from Schuler, who will be discussing on efficient battery can and lid manufacturing for high volume production. And at the end of the presentation, uh, the audience can ask directly any questions if you have to Markus Roever related to battery can and lid manufacturing, and that's the whole point of having open talks. Now I request Markus Roever to introduce himself and start with the presentation. Thank you.
Yeah, thank you very much, Vikram. First of all, I'm very happy that I can participate in this new format of batteryline.com. I'm looking forward to the discussions we have. Myself, I'm an engineer. I'm working since 1995 for Schuler Group, and I'm in charge for the equipment for battery can stamping for prismatic and cylindrical cans at Schuler. And yeah, then I think we can start with the presentation. I try to be short, that we have enough time for our discussions. So Vikram, would you share the slide deck? Perfect, yeah, thank you. Okay, yeah, Vikram asked me to discuss the efficient battery can and lid manufacturing for high volume production. For sure, it's a big topic for 15 minutes presentation. So I try really to wrap up the most important points which I see in this regard. So Vikram, can you go to the next slide? Yeah. So I will start with a brief overview of the manufacturing process of one format, because I cannot talk about all formats, cans and lids in this time. And I would like to discuss or show the challenges I see for the supply chain of these components for the cell manufacturing, and share with you some cost analysis we did in a case study of one customer, and then come to the solutions we found for the identified challenges, and we'll end with the key success factors I see for efficient production. Please go ahead. Yeah, just as I said, we will talk about prismatic cells and cylindrical cells, can and lids. I will not touch the pouch cell, which is also some kind of forming, but not the hard cases, literally. So this is the topic of today, prismatic and cylindrical cell. Please go to the next. Yeah, this is one example for production steps. I will here take care of the cylindrical battery cans. As example, in prismatic cans looks a little bit different, but not so much different at the end. And also lid production is for sure different, yeah, but in principle, there are forming stages. In this case of the cylindrical battery cans, you have at the first incoming coil material, you do have to produce a cup, you do a blank and draw, Then you have certain drawing steps, ironing steps, and trimming operation. In this forming applications, one is using lubricants, emulsion, oils. This have to be washed off the product. Also the particles has to be washed up. After washing, there is the possibility that if there is this production facility located in a cell manufacturing unit, that you go through the wall directly into the cell assembly. Usually there is then a buffer to balance out the two production lines. Or if you are in an offsite, maybe a supplier, you do a visual inspection of the product, and then you pack it into trays, and then you send it to the cell manufacturer. For prismatic cans, it looks very similar. You have also this deep draw process rule at the beginning, or impact extrusion process rule, where you have at the first step the impact extrusion press, but then you have also some ironing and trimming operations and the washing as well. For lids, you have the forming operations on a high-speed press, where you also apply coining, forming, trimming, and you have also to wash the product. So in principle, you see this is very similar. For sure, the production lines itself have different sizes, but this depends also on the production volume, and I will come to this later. So Vikram, can you go on? So what are the challenges I see right now for supply chain in the, let's say, growing markets in Europe, North America, and India? So these are markets where the gigafactories are still to be in-built or will be built. First thing, there is, for this kind of component, there is no supply chain, because so far there was no cell production. Cell production, which is already existing, is usually from Asian cell manufacturers, which brought along their supplier on site. And for new gigafactories, there is still a supply, or there is a supply chain to be developed. You have to start from scratch, more or less. Yeah, it could be a good thing, but it is the situation. Everybody who would like to enter this market is looking at very high production numbers in the future. So everybody's saying, yeah, I would like to produce, I don't know, 20 gigawatt, 40 gigawatt hours, which translates then into a certain number of can. But at first you have a certain ramp up. What we're facing right now, there's a slowdown in the market. Things are getting not so fast done as anticipated. So you have a situation that you start with a relatively low number, but you have to be efficient, but also with a high number you have to be efficient. So this is a challenge. Product specifications are still changed frequently, means the drawing of the product, the requirements, sometimes also the cells itself are still under change because of certain new technologies which are arising. You have now the LFP cells, which are very successful, where some suppliers are changing now their chemistry to be competitive. We are talking about other chemistries. We are talking about even then solid state. So it is also a little bit very volatile situation where you don't know, okay, what has to be produced, maybe not tomorrow, but maybe in 3 to 4 years. And in these markets, maybe cost of labor not applying to India, but at least to Europe and North America, and energy costs as well, and also construction of sites were getting or is now much more expensive than we are used to be maybe before the pandemic. So these are the challenges where a new supplier has to square the circle. So when we talk about efficiency, we have to talk about, okay, what are the factors what we are dealing with when we have such a can stamping operation. And what we did, we made a cost analysis at a customer, where we said, okay, what is the factors which are determining the production cost of the can in this case. It's also here a cylindrical can, and we made an index. Yeah, so these are not euros or so; that is percentages. And what it's easily to see that the raw material, in this case, nickel-plated steel, is a big topic for the product cost, followed by labor. Yeah, okay, this was customer in Europe, I have to say, and also the construction cost for the new building. Yeah, this was also a big impact, and then followed then by other direct materials. This is then usually lubricants and detergents, and then maintenance and utilities, yeah, the power like gas or electricity. And you have then also non-operational cost, the depreciation of the investment. Yeah, this is another block. But when we focus about the production process itself, we have, I would suggest to focus on this material, how to bring up the utilization of the material, to see how we can reduce the labor cost, which means number of operators, and also the footprint of the production unit to reduce the construction cost. Yeah. So in my opinion, these are the key factors. So let's move on. Okay, here's one example, material utilization, where we facing an expensive raw material. This is could be the nickel-plated steel for cylindrical can, or aluminium for prismatic. And here, in case of deep draw applications, we have the issue that we are using only a certain part of the coil material. So we buy the coil, but we do only use, maybe in case we use a narrow coil with a 1-hour operation, only 79% of the incoming raw material. The rest goes directly back into the scrap. Yeah, so this is not a good solution. And what can be done here, what should be done really, that you try to optimize the material utilization by using wider coils. I would suggest to look what is the widest coil available in your market, and then you go for this coil width, because what you see here, and this is just the math behind it, the more blanks you place in this coil, the better the material utilization gets. And this is really a big portion. So if you see from 1 hour to 8 hours, it's already 11% you gain in utilization. Yeah, and this is what you see. In the example was 50% of the product cost. That means 11% translates in 4.5% cost down for your can price or can cost. Okay, next please. Yeah, what can we do to reduce the number of operators and reduce the footprint of our production lines? Here, our proposal is to do more cans per stroke. We are already seeing on the cupping press, we can go up to 6, 8, even 12 hours, depending on the product. It means there is one big machine which is then feeding the deep draw and ironing presses, and also at the deep draw and ironing presses, there we can use die sets with multi-out. We have realized 4-out die sets for the can size 46, We have realized 6 out die sets for the can size 21700. That means you have less machines, yeah, and means you have less operators and less footprint. So this relatively a big impact then in your shift operation, in your manning, and also in the layout of your production facility. Okay. Yeah, but there is also some constraints, I would say, because as I mentioned at the beginning, the volumes are promising, but they are not really guaranteed. Yeah, so you could say, okay, I go for a production line for 300 million cans, but the cell manufacturer maybe says he will reach this, but you're never sure, will he really? Or will it be only 100 or 50 million or even 25 million? So that's why we developed in the last 2 years a system, a modular system, which can be grown over time. So where you have to compromise maybe on material utilization at the beginning, but you're able to really gain this utilization when you are growing. Yeah. So in this example here, we have proposed a concept for a customer to start with 25 million per year with a product, having only a 2-out cup and 1 out at the PP press, which can be then grown to 50 million with better material utilization, and then even to the next step to mass production between 100 and 300 million, adding here equipment, yeah, but you can still use the same press for deep draw and wall ironing. Yeah, you exchange the die sets, you add a bigger cupping press, and then you can grow over time. And you're getting, it's clear, the concept is to reduce the investment at the beginning, but not to have an investment where you can just add on single machinery, because then you would have the situation when you come to the point where you have to produce 300 million, you have maybe 20 machines standing there, because, and then you need these operators, you need the footprint. So you have to start with a relatively low investment, but when you grow, you should really in the position that you have then also efficient production line with the big volume. Yeah, so you have this growing concept we suggest to the market. Another thing is what I mentioned, the products are changing. Yeah, we had one example from the last year where we said customer had already 300 million. I said very good. So we said, okay, we can use a copper white coil with 1 meter coil width. We can have 6 PP presses, each with 4 hours, very efficient, very powerful line. But then he said, okay, but I have also a second product. It's not a 300 million. I don't know which of these products. I don't know the ratio between it. I only know they will come, and somehow this will sum up then to 300 million. Could be 50-50, could be 25-75. So we said, okay, what we should not give up this big advantage of a small footprint, high productive line with less operators. But on the other side, we have to add flexibility to run 2 products at the same time. I have to mention it was also required 2 products at the same time. Yeah, so it's the same day. Yeah, it's simultaneously. So what we propose, okay, we add a second cupping press, which is an additional investment, and we can add the possibility to split the line between the 2 products so that we can run one product or the other. We can do a mix in between. So we enjoy here the big or good material utilization, less footprint, but we have adding the flexibility to run different products at the same time. So it's also an example for efficient but flexible production. Yeah, so I think I need to finish. That's good. That's my last slide. Yeah, just as a wrap up, what are the factors which are the input for efficient production? You have for sure the machines and the line integration. You need these dedicated partners. You need the part from the human resources. Yeah, as I said, you usually have new production facilities, also new people. We have not the experience, so you need training, launch systems, and so on. The operational support from the suppliers, local services, remote services, digital cloud services, whatever. So we can discuss for hours, but I need to come to the point then. And the last thing is the process support, tool and die for different products, simulation, sampling. You need the input recommendation on direct materials like steel, detergent, oils, and so on. Yeah. So this has all to come together when we talk about efficient production systems. Yeah. Thank you very much. I think on the last slide you see my contact details, and I'm looking forward to your questions. Okay, there is only one question in the chat. What are the difference between prismatic cans and cans for blade cell? Do you see a big cost difference between both? Yeah, sure. There is a cost difference. Blade cell, depending on the size, they usually are formed and laser welded or welded, and they are not made by metal forming. Also, when I say about deep draw or impact extrusion, so there is for sure also a cost difference, because I'm not an expert for roll forming and welding, but I would imagine this is relatively slow in comparison to metal forming processes as we see for prismatic cans. There are some blade cells when they are not too long, so I would say up to a length of 200, maybe 280 millimeter. You can still apply the traditional metal forming techniques, which gives you then a good advantage over the roll forming and welding. Yeah, any more questions? Did you plan other webinar on prismatic? I think this goes to Vikram then. How does change in chemistry affect the design of the can? Well, I'm not really competent to answer this question. We see a lot of different can sizes, and I'm not sure if this is about different can types like LFP or NMC. There are also some claims in the market. They say they have the same size, independent of the chemistry. But I'm really not sure about it. So better not to answer this, telling you something wrong. Regarding prismatic, I would love to have this also some words about prismatic, but it's up to batteryline.com, I would say. Other questions? To be the case.
Markus, can you hear me?
Yeah.
Yes. We have a question. What support services do you offer post installation to ensure the smooth operation of the equipment?
The on-site services. Also, yeah. Yeah, what we offer, and usually we have also in every project, this is part of the scope, is a launch assistance. So we install the line, we start it up, do a test run, but then we stay on site for, sometimes depends, 10 weeks. We have one case where we stay on site for 1 year for launch assistance, where we, at least during day shift, we are present with one guy, up, sometimes it was the case up to 4 guys, to support the customer, hands-on training on the job. And this is very well received from the customers. And I think it's also necessary if you have this, as I said, very often completely new greenfield operation. Yeah.
We have a question by Matthias. Is the cost of breakdown in a prismatic cell is similar to that of cylindrical cell?
It is similar, however, I would say for prismatic the material portion is even higher, because you have here not this nice round blank, at least for deep draw, but elliptic or somehow shaped blank, which brings down your material utilization even more down. So you can have some countermeasures like using impact extrusion, but in overall, the material content in the cost of a prismatic can is, I would say, maybe 60 to 70% instead of 50%.
We have another question by Volker. Do you see aluminum or stainless steel as a alternative material for cylindrical cells?
Yeah, I'm not the cell designer, but what I can tell is what I see on the market. So we see already aluminum as a raw material for cylindrical cells. We have projects where customers are asking for it and would like to do it. For stainless, I have to admit I don't see this at the moment.
Okay, we don't see any more questions from the audience, but if you have any questions, please reach out to Markus Roever directly, or you can write to us at info@batteryline.com. And before we end the webinar, I would like to mention that batteryline.com will be present at the battery show in Detroit from 7th to 10th October at booth number 4800. Be sure to visit us. Thank you once again to our audience who have joined us live today. Yeah, we look forward to see you at the battery show in USA. Thank you.
I have also to thank you for the opportunity. Have a great day, everybody.